Today we're going to try and answer the question, how can we solve trig equations whenever we have different trig functions in the equation? Well, to solve those trig equations with different trig functions, you have to use trig identities and algebra to simplify until you can get each factor to only have one trig function. Okay, so let's look at some examples of that. In this first example, we have the cotangent of x times the cosecant squared of x is equal to 2 cotangents of x. So my first step is I'm going to move everything to one side to get cotangent of x, cosecant squared of x, minus 2 cotangents of x equals 0. Now I can factor out a cotangent x out of each of these. So that would be cotangent of x times cosecant squared x minus 2 equals 0. So now since each factor has only one trig function, then we can set each factor equal to 0 and solve. So I have the cotangent of x is equal to 0, and cosecant squared x minus 2 is equal to 0. So I'm going to go ahead and solve this cosecant side out. That equals 2. So the cosecant of x is equal to the square root of 2. And we saw that this occurs whenever you have 1 over the square root of 2 divided by 2. So now remember that cotangent is the x over the y. So, and we need that to equal 0, so that's going to occur whenever we have 0 over 1 or 0 over negative 1. So the only times that we see 0 over 1 as x over y would be 0 over 1 and 0 over negative 1. So I have my solutions of pi over 2 and 3 pi over 2. Also remember that cosecant is 1 over the y value. So I'm looking for when the y value is the square root of 2 over 2. That occurs here at pi over 4, and the y value square root of 2 over 2 at 3 pi over 4. So I've got also the solutions pi over 4 and 3 pi over 4. In our next example, we have the sine of x in degrees plus cosine of x in degrees, cotangent of x in degrees equals 2. Well, in the last example, we were able to factor out something, and this time we're not able to. So we're going to have to change this cotangent into sines and cosines and see where we can go from there. So here I have the sine of x plus cosine of x. And cotangent is going to be the cosine of x over the sine of x equals 2. So now I have the sine of x in degrees plus the cosine squared x over sine x. Whenever I'm adding two things and one of them is a fraction, I have to get a common denominator. That common denominator is going to be sine x. So this needs to be multiplied by sine x over sine x. So if I multiply this by sine x over sine x, I come out with sine squared x plus cosine squared x over sine x. Oh, sorry, and this was equal to 2. Well, we know the identity sine squared x plus cosine squared x is equal to 1. So this is 1 over the sine of x is equal to 2. And 1 over sine x is cosecant of x. Sorry. Cosecant of x is equal to 2. Well, we know that cosecant is 1 over y, so to get it to be 1 over 2, or to get it to equal 2, that it has to be 1 over 1/2. So I'm looking for y values of 1/2. Okay, so y values of a half occur here at 150 degrees and 30 degrees. And I know that I'm answering in degrees because the whole time our x's have been in degrees. So my answers are x equals 30 degrees and 150 degrees. Okay, so 2 sine squared x plus 3 cosine x equals 3. Well, in this example, we have a sine squared and a cosine, so one of them is square term, one of them is not. Like, the best thing that we can do here is try to get everything in the same type of trig function. So I can change sine squared into some kind of a cosine by using that the sine squared of x is equal to 1 minus cosine squared. So I'm going to start by changing that. I'm going to put 2 times 1 minus cosine squared x plus 3 cosine x equals 3. Now I'm going to distribute, combine like terms, get everything on one side. So I've got 2 minus 2 cosine squared x plus 3 cosine x minus 3 is equal to 0. Now, I'm going to move all of this stuff to the other side, or just change all the signs. So I end up with 2 cosine squared x minus 3 cosine of x plus 1 equals 0. The only reason I change all the signs is because I didn't want a negative 2 cosine squared. I didn't want my leading term to be negative. Okay, so now I'm going to factor, because I've got a cosine squared and a regular cosine. So this factors down to 2 cosine x minus 1 times the cosine of x minus 1 equals 0. And again, if you need a review of factoring, you can just treat this as 2x squared minus 3x plus 1. Use divide and slide, and you'll end up in the same spot. You'll end up with like 2x minus 1, x minus 1. But remember that we're dealing with cosines. So now I'm going to set each factor equal to 0 and solve. So I've got 2 cosine x minus 1 equals 0. So 2 cosine x, 2 cosine of x equals 1. The cosine of x equals 1/2. And cosine x minus 1 equals 0. That's just going to be cosine x equals 1. So I'm looking for x values of 1/2 and of positive 1 in radians. So x values of 1/2 occur at pi over 3. These x's of 1/2 also occur here at 5 pi over 3. So I've got my solutions pi over 3 and 5 pi over 3. And then for an x value of 1, that's going to occur here at 0 pi. Or I could also say that's 2 pi. So either of those answers are fine. Secant squared x equals 2 tan x plus 4. So we're going to use the same thing that we did last time in trying to make this all one trig function. Secant squared x is the same as 1 plus tangent squared x from our identities. So this equals 2 tangent of x plus 4. I'm going to move everything to one side and combine like terms to get tangent squared x minus 2 tangent x. And then 1 minus 4 is minus 3 equals 0. Well, this is much easier to factor because I don't have any term in front of this tangent squared x. So the two numbers that multiply to negative 3 and add to negative 2 will give us the tangent of x minus 3 times the tangent of x plus 1 equals 0. So we set each factor equal to 0 and solve. We have the tangent of x equals 3, and the tangent of x equals negative 1. So we look at the unit circle, and the tangent of x equals 3. That means some y divided by x is going to give us 3. Well, that never happens. Okay? So that solution does not exist. Now the tangent of x equals to -1, the y over the x equaling -1, that's going to happen twice. Here at square root of 2 over 2 divided by negative square root of 2 over 2. And again over here at 7 pi over 4 because we have one positive and one negative. So my solutions are x equals 3 pi over 4 and 7 pi over 4. Again, don't forget, at any point in this video you can pause, rewind, do whatever you need. Okay. One more example. Alright, in the last example, secant of x plus 3 equals -2 cosine of x. There are multiple ways that we could approach this problem, so this is just one way. I'm going to use the identity that the cosine of x is 1 over secant. So I've got the secant of x plus 3 equals -2 times 1 over secant of x. Now, to get rid of this secant of x in the denominator, because this is an equation, unlike identities, right? If an equation, whatever you do to one side, as long as you do it to the other, you're fine. So to get rid of the secant of x in the denominator, I'm going to multiply both sides by the secant of x. Now that's going to cancel these denominators, or that denominator. And I can distribute on the left side to get secant squared of x plus 3 secants of x equals -2. Now I've got it down to one trig function. Move everything to one side and factor secant squared of x plus 3 secant of x. Secant of x plus 2 equals 0. A factor, that'd be the secant of x. These are all in degrees. Secant of x plus 2 times the secant of x plus 1 equals 0. Set each factor equal to 0 and solve. Secant of x equals -2. And the secant of x in degrees equals -1. So if it's going to equal -2, and this secant of x, this is 1 over the x value. So I need it to have 1 over -1/2. So I'm looking for x values of -1/2. This is 1 over x, so I need 1 over -1. So I'm looking for x values of -1. These are all in degrees, so the x values of -1/2 occur at 120 degrees and 240 degrees. And then the x value of -1 occurs at 180 degrees. Alright, and that's all.